শেষ করে আমাদের যাবো আবার ব্রেক একটা ঝামেলা সেটা একটু আমার তো পছন্দ নাম আছে একটু দূরের থেকে আসছি ভাবি যে শিকা অবস্থা অনেক দূর প্রায় 600 কিলোমিটার আমি প্রেজেন্টেশন শেষ করে পছন্দ নামাজ পড়বো জামাত অলরেডি শুরু হয়ে গেছে টাকা নেই
জায়গা নাই
সময় আছে ব্লকটা তো মাত্র শুরু হইল আপনার তো 45 সাল
আমার মনে হয় আপনি
ভিডিও করতে পারবো
আপনার ডক্টরাল ডিগ্রি আমি বাংলাদেশে মেকানিক্যাল আগে পাস করছিলাম
কত দেয়
2003
চিনি আমি আমাদের লেভেলে সে কাজ করতে আপনি 2003 না 3 তো গেছে 3 না 5
আপনি কি এখন
ছুটি নিয়ে আসছি আমাদের কোথায় ছিলেন চাকরি করছেন
আসি আসি Allah Allahu Akbar Allahu Akbar Alhamdulillahi Rabbil Alamin Ar-Rahmanir Rahim Maliki Yawmiddin Iyyaka na'budu wa iyyaka nasta'in Ihdinas mustaqim Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin Qul huwallahu ahad Allahu samad lam yalid wa lam yulad wa lam yakul lahu kufuwan ahad Allahu akbar Sami'allahu liman Allahu akbar.
I'm good friend.
I am permanent. I have a permanent contract with a Japanese company, but I don't know the decisions of us.
Enggak balik pas pulang naik kereta.
My name is Don.
Saya udah tiket PP berisi dengan panitia. Dengan panitia. Separuh di oh
Well, but yeah, always. I converted One time I had a student.
45.
Then I got so there is like one knowledge and science. People with really knowledge and science recognize it. I hope I have that. Since so there is knowledge, we use wisely this knowledge. Knowledge, but they can destroy ethics. We have wise.
So, brother, assalamu alaikum.
Waalaikumsalam.
We are going to start our the last and fourth session very soon. And me, Muhammad Ghulam Sarwar, I just conduct this session in the state of Dr. Muhammad Nurul Islam. So, in this last and in this fourth session, it consists of 2 invited talk and only 1 oral talk. There was another oral talk, but it was already conducted before. So, the fourth session is the allergy and environment. So, I asked Brother Mr. Muhammad Shamirullah to deliver his talk. Please.
Dear brothers and sisters, Assalamu alaikum. I came from Japan Advanced Institute of Science and Technology, JMRIS, which is Ishikawa Prefecture in Japan. First of all, I would like to thank the organizer for giving the opportunity to me to come in here. Today I would like to talk about investigation of the nonlinear optical interferometry for the interface of indium tin oxide and iron pathology. This is the outline of my presentation. First of all, introduction, structure of organic light emitting diodes, OLED, nonlinear optics, second harmonic generation, SHG, methodology, optical experimental setup, and experimental results with interference patterns, and finally, conclusion. Recently, functional organic materials, in particular metal patholocylene, have made tremendous research topic due to their application points of view such as organic light emitting diodes and organic field effect transistors. In order to improve the device performance, the interface electronic stress between indium tin oxide and organic layer play a crucial function when the device is under working. On the other hand, optical second harmonic generation is becoming a powerful method for investigation of surface and interface studies. So, in this regard, an attempt has been taken to observe SHG phase from the interface between ITO and organic layer through the interpretation of the nonlinear optical effect. Now, I am going to talk about the nonlinear optics. The nonlinear optical response is described as a power series. In here, Chi2 and Chi3 are the second and third order nonlinear optical susceptibilities. That terms belongs to second order nonlinear polarization, and that terms belongs to third order nonlinear optical polarizations. Now, what is second harmonic generation, SHG? Actually, SHG is a nonlinear optical process where 2 photons are converted at the same frequency omega into double or second harmonic frequency 2 omega. In here, fundamental electric field with frequency omega and SHG light produced from the sample, so which frequency is double 2 omega. Where k omega and k2 omega are the wave vectors at the fundamental and SHG wave respectively. This is the theoretical approach of SH interference. Actually, in my method, in order to produce SH interference pattern, I used alpha SI2 0001 crystal system as a reference source of SHG. In here, I rotate the alpha SI2 crystal around the surface normal. So this is the basic interference equation for producing of SH interference pattern. In here, E1 is the SH electric fields comes from the alpha SI2, and E2 is the SH electric fields produced from sample in here. And phi is the phase difference between sample and alpha SI2. This is the optical experimental setup in my method. So in here I used neodymium egg laser with wavelength 1064 nanometer, pulse duration 30 picosecond, and repetition rates 10 Hz. And this is the optical system: piezo, mirror, and half-wave plate, polarizer, filter, lens, and this is the reference sample in here, and lens, polarizer, filter, and lens. And finally, SHG was detected by monophotometer, PMT, photometer tube, amplifier, and then computer. Okay. This is the experimental result of my system. First of all, I used ITO, bare ITO, without the organic layer. So in that case, I observed the SH interference pattern in the periodicity of SHG length. So this is the periodicity pattern. After that, I use ITO with organic layer. So this is also the SH interference pattern for different distance. So in here I observed, so in the previous slide, so for example, at the distance 20, this is in this way, without organic layer. And with organic layer, I obtained this pattern. That means the phase shift. It is clearly observed, the phase shift from the organic layer dispersion. On the other hand, I also observed ITO with iron pathocyanin interface layer. I also get this pattern, SHG interference pattern. Okay. Now, I am going to talk about the phase shift calculation at the interface. After getting the SH interference pattern, I used the fitting equation. So, and from the fitting equation, first of all, I calculated the phase angle of the only bare ITO, which is 69 degrees. After that, I use ITO pathocyanin layer system. The phase angle of the ITO pathocyanin system minus 81 degrees. So that means the phase shift at the interface between ITO and pathocyanin layer is 150 degrees. So which is not 180 degrees. That is the interesting point in here. And similarly, I also calculated the phase shift at the interface between ITO and iron pathocyanin layer, which is 129 degrees. So normally we know the phase shift is 180 degrees, but in that case, not is 180 degrees. It is deviated from 180 degrees. Why? So the first answer is the chi2 is the not real value. It is the imaginary value. So that's why it is deviated from 180 degrees. So that is the interesting of my result. And previously in my laboratory, one PhD student, she did the result. It's another method, and she obtained actually. She came from Malaysia actually. She obtained in the case of ITO copper pathocyanin layer 140 degrees. And in my case, I get actually the phase shift at the interface between ITO and iron pathocyanin layer 129 degrees, which is near about close result. So, but this technique is different. So in her case, he just only translated the alpha SH system, but in my case, I rotated the alpha SH material. So, and previously in my laboratory, and another Egyptian student, he assumed that phase shift is he assumed pi, 180 degree. Actually, because chi is a complex value, and another thing, when SH intensity comes from the sample, it does not depends on the only intensity. It also depends on the phase, because one SSG comes from IPO bulk and IPO interface and PC. So finally, all contribution added to the SSG signal. That's why we get 150 degree. So which is not 180 degree. So actually, finally, I conclude this interferometry technique actually will be applicable in future in order to get the phase information of such type of interface. Okay, that's all. Thank you so much.
So thank you very much for your presentation. So there's enough time for the question. If you have any question, please. Because we still have 2 minutes.
Can I have some
Yes,
questions?
please.
Maybe it's a little bit general for semiconductor which using organic material. I think it has the disadvantage for its durability.
Yes.
How about your
Yes, yes. Actually, this is the device in here, glass substrate and anode in here, ITO, and that is the whole transport layer. Actually, in my system, I observe only anodic side. Only observe anodic side. Actually, because the interface electronic system is very important and crucial, because when the device is under working, the problem is that in here, so if we cannot mass more efficient the hole to the hole injection layer to the, actually in here the emitting layer is a whole device. So if we mass more hole transfer to the organic emitting in here, actually that means as much as possible the barrier so reduced in here. So in my system, so barrier is about minus 0.02 electron volt, very low. That means it is easier to transfer whole injection into the whole injection layer. So actually, this is the non-linear optical study actually. Actually, it's another group, they are working in the performance and efficiency. But in my case, actually, I observe only non-linear optical system actually. And what happens in here? What is actually in phase shift? So phase shift is important in here in order to the device performance. I think that information will be applicable in the future electronics technology. I think so.
Thank you.
Is there any questions? If not so, then we can proceed for the next talk. So thank you very much for your nice talk. So thank you again. So I asked the next speaker from Tokyo Institute of Technology, Mr. Sadono. Please.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, thank you for the introduction. I will introduce again myself. My name is Aidiuda Sadono. I'm from Tokyo Institute of Technology. Now I'm still doctoral first year student. My presentation topic today, the title is the development of the CIJ solar cell on flexible substrates. This is the outline of my presentation. First, I will start with the background. Okay, so I think we already know we have some environment energy problem nowadays, and one of the solutions is by using the solar cell power generation. There's a lot of material to use this to make the solar cell, like silicon that already discussed before. But in order to reduce the cost more, we think of use the thin film solar cells. And one of the material we choose is the copper indium gallium diselenide, or we just short it CIGS. This material have several advantages such as controllable band gap, high absorption coefficient, and also high efficiency. And the recent efficiency is more than this. Actually, is 22.3%. This is the standard structure of the CIG solar cell structure. The CIG solar cell structures was deposited on top of the soda lime glass. This glass is really cheap and have high enough durability. However, if we change the soda lime glass into some flexible substrates, we can fabricate some lighter solar cell, which can decrease in the infrastructure cost and also increase its field of application. So the solar cell is not only a big one, but also we can use on top of 10, building with some curve or some portable solar cell. There are many kinds of the substrate for the flexible solar cells, like such as polyimide, stainless steel, mild steel, enamel steel, and others. However, there's also several challenges, such as low deposition temperature, lack of sodium source, and impurity from the substrates. This sodium source is known to improve the CIG solar cell efficiency. Here, as for our research, we choose polyimide film. This polyimide film known to have high stability, which is more than 450 degrees Celsius, and also it has no impurity diffusion, which the other three still have it. If the substrate have impurity diffusion, it will decrease the CIG solar cell efficiency. However, this polyimide film still have some problems, such as it needs external sodium incorporation and it still needs low temperature deposition. For normal CIG solar cell, deposit on top on more than 500 degrees Celsius. So we need to decrease the temperature lower. Even though and also it was reported recently that the solar cell using this kind of flexible substrates have efficiency around 20.4%, which is near